talk about security today. I'm going to talk about the OWASP Top 10, well, different versions of the Top 10, and OWASP ASVS. Before we dive into, there's one keyword in the title, and that's OWASP. In case you're not familiar with OWASP, OWASP is a non-profit organization and stands for the Open Web Application Security Project. And what started out as a project to improve security knowledge among web developers grew to this big international organization with a lot of local representation, local chapters, holding meetings, holding conferences and things like that. Other than organizing a community, OWASP also produces results. OWASP produces documents like the OWASP Top 10, ASVS, produces tools, builds projects. All of these things are part of OWASP. And all of that is free and open for everyone to use because it's a non-profit and their mission is essentially improving web security. Today, we're going to talk about 3 specific OWASP documents. We're going to talk about the OWASP Top 10, which is probably the most well-known that many of you will be familiar with. We're going to talk about another Top 10, the Top 10 of proactive controls. And then we're going to talk about the OWASP ASVS, which is a more elaborate document going into a lot more depth on certain aspects. Before we get started, I'm Philippe. Thank you for the introduction. I'm from Belgium, so I understand German a little bit, but not too well. So you can talk in German about me understanding. Anyway, I do speak security, and I deliver security trainings around the world for companies, for developers, on essentially a level that is helping developers build better applications. So I cover security in depth on various different kinds of topics. I'm also involved in a SecOpDev course, which is a week-long course held in Belgium, given by international experts on their domain. So if you're a developer, that is definitely a place you want to be next year in February. For the record, I'm a Google developer expert, which is a recognition by Google for the work I've been doing for the community to teach them about security. It's not a position at Google. I'm not affiliated with Google in any way, which is something that confuses many people around the world. With that out of the way, let's dive into the OWASP and the OWASP Top 10. I want to talk about the traditional OWASP Top 10 first, the document that has been around for over 10 years, that has seen revisions over time, and that essentially focuses on the top 10 most critical risks in web applications. So if you're familiar with the top 10, you know this version. This is the 2017 edition you can see on the right, and that are the critical risks that web applications face today. So you can see in this overview picture, which is taken from the full document, there's a new version every few years. The 2017 edition actually got some feedback, let's call it a controversy from the community. They didn't agree with the first version, so OWASP went back to the drawing table, or the team from the top 10 at least went back to the drawing table and built a second, better version that got accepted by everyone. As you can see, there are some important things in the OWASP Top 10. Injection is problem number 1, has been problem number 1 for quite a while. Injection is about things like SQL injection, command injection, and all of those things. So you can see, it's about not necessarily the most common vulnerabilities, but the most risky ones, meaning that they do some kind of a risk assessment on these items to see how bad is the problem, how exploitable is the problem, what are the consequences of the problem, and based on that, these subjects or topics get a score. And they're ranked from the most risky to the less risky ones in place number 10. Of course, it shouldn't come as a real surprise that the most of the risk lies at the server. So if you look at the top 10, or a majority of the items, many of those focus on server-side problems. So injection situates on the server. If I'm an attacker and I can compromise the web server through command injection, that is a lot of power for me as the attacker. I can compromise the application, access the files, steal data, whatever I want. Similar, broken authentication is essentially a backend problem. Even in today's modern landscape where we have front-end application APIs, many of these problems remain on the backend, maybe in different forms than before, but they're still there. Sensitive data exposure is number 3 in the top 10, also sits essentially mainly on the backend. We have data at rest in the database that might be exposed. You can steal data from the server. You can inadvertently leak information, things like that. Also, data exposure matters on the protocol level. So HTTPS is definitely a big part of OWASP item number 3. You should deploy HTTPS to prevent data in transit from being leaked. And we can go on like this. You have XML external entities, a sort of an XML injection attack happens on the server. It's a server-side problem. Broken access control is a server-side problem. If you can get access to resources on the server, if the attacker can get access there, you might be in trouble and you have a serious problem. And then if you go a bit further into the OWASP Top 10, you see that the problems start shifting towards the client side. So cross-site scripting is in essence a client-side problem. Malicious code executes in the browser of the victim and allows the attacker to do nasty things there. In reality, many of these nasty things will affect the server-side application as well. But this shows you that the risk of a server-side vulnerability is much larger than the risk of a vulnerability that can be exploited on the client side, hence the ordering in the OWASP Top 10. So if you can get full control of the web server, then you honestly, as an attacker, don't really care about cross-site scripting. But if everything else is patched, then you might want to start looking at XSS as a way to find your way into the application. And that's essentially what the OWASP Top 10 brings to the table. It's an overview of vulnerabilities. It's not an exhaustive list. It's just an awareness document. And that's really important. The goal of the OWASP Top 10 is not to give you a security program to follow. It's not a checklist to see, is my application secure? Oh yeah, I've covered each of the 10 items, I'm good to go. It doesn't work like that. It's about raising awareness. And that's why the list is kept at 10, for example. Because if you need to talk to a developer who has never heard about security, and you come with a list of 325 items, you're going to lose them at item number 2 probably. But if you tell them, like, here are 10 absolutely critical things that you should be doing in your application, that's a different story. 10 is easy to communicate about. 10 is manageable. 10 isn't overwhelming to get started with security. Of course, if you're a big financial organization and you've been doing security right for 10, 15 years, then the OWASP Top 10 shouldn't come as a surprise. It's not supposed to help those organizations. It's supposed to raise awareness among developers, among teams across the world, that there are these web security problems that we keep seeing over and over again, which are really dangerous and should be addressed. I want to dive into detail on one of these items. I want to talk about broken authentication in a bit more detail, because I'm going to use that as kind of a running example throughout the presentation to keep giving you examples of what the problem here might be. So if you look at the OWASP Top 10, at the sheet that they offer there, essentially you get a rating score. It's very exploitable, it's very dangerous, it allows an attacker unfettered access to the backend application. If you think about authentication, you might think about something like this, a login form where you can actually authenticate to the backend. This is how most applications today still do authentication. Well, from this example, you can probably derive that I don't have a very secure password in this application. It's 4 characters. It's even test, which is a really bad practice, but you get the idea. This is an example training application, so it doesn't matter. But for OWASP, authentication is more than the login procedure. It's more than simply authenticating. Because what we essentially try to do is we try to make authorization decisions. In the backend, we want to decide what is this operation and is this allowed by the user making that operation, yes or no. And to do that, we need authentication. We need to know who is making this call. That's where authentication fits in. We're establishing the identity of the entity making the request to our protected resource in this case. And here it is a user, but it might just as well be a machine. These instances happen as well. And this is where the picture should have ended. Normally in a straightforward system, you log in and the backend knows, is this allowed, yes or no. On the web, it's not that simple. On the web, we have a stateless protocol and we need to propagate that authorization information to the backend one way or another. And that's where session management comes into play. Because session management is going to keep track of your previous authentication, keep track of that state, allowing the backend to keep making authorization decisions based on that one authentication that happened some point in the past. And for OWASP, at least for broken authentication in the top 10, authentication and session management belong together. Because a vulnerability in either one of these will cause a serious problem in the backend. It causes the breaking of the authentication mechanism. It allows the attacker access in the name of the user to the backend, which is potentially serious problematic. So if you look closer, there's not only the categorization of how exploitable and how dangerous something is, they also have various items on what not to do, what a vulnerability entails, and what to do, how to fix the problem. So I'm not going to go over each and every one of these items, but if you look at a few examples, there's this pitfall where if you have a vulnerability, if you're using hard-coded passwords, which sounds fairly obvious. It's a bad practice to do hard-coded passwords. If I tell you this in a presentation, everybody's like, yeah, of course, who does that? Come on, nobody does that. Well, a lot of people do. Especially in the IoT world, a lot of security cameras or whatever come with default passwords. And they're exposed on the internet, and everybody can simply grab, take a list of common passwords and try to log in. These things actually do happen in practice. Other things are insecurely storing your passwords. You all know today how we have data breaches all over the internet. If one of these services stores your password in an insecure way, an attacker can grab it from there, and now he has a potentially valid password for other applications as well. Not only the same, but also for others. It's a widespread problem. On the prevention side, there's a few interesting items. You should, for example, prevent enumeration attacks and brute force attacks. So you should prevent someone from learning if a user exists in the system, yes or no, and you should also prevent them from just trying valid credential combinations to see, trying credential combinations to find a valid set of credentials. And at the top of the list is maybe the most interesting item: implement multi-factor authentication. And while this is really solid advice because it solves many of the problems, I'm not sure whether it's supposed to be on top of the list. I would disagree with that, because I think there are more pressing issues to address first than implementing multi-factor authentication. But I don't need to agree with the OWASP Top 10 because it's an awareness document. It's intended to create awareness around the problem. It's intended to inform developers like, hey, there's a lot of problems with authentication. You should probably look into this. You should probably figure out if this is something you need to address. Oh, and by the way, this multi-factor authentication mechanism is really good. It's awesome. It solves a lot of the problems. But what the OWASP Top 10 maybe doesn't really go into detail in is the impact of implementing such a mechanism. Your users will have to use it. You, as a developer, will have to implement it. And that might require time and skills to actually get that right. And again, that's okay, because the goal is to raise awareness. The goal is to tell people, hey, there is this multi-factor authentication thing. You can use all of these different methods, and that's how you would approach that. And that's what's going on here. So the OWASP Top 10 is about raising awareness. It's a brief overview of do's and don'ts that you should or shouldn't be doing in your web applications. The advice is independent of the application, doesn't really take user impact into account, things like that, but nonetheless, it is valid advice. That brings us to the second document from OWASP, the OWASP Top 10 Proactive Controls. It's a bit confusing that they're both top 10s, so I'm going to have to say top 10 proactive controls a lot of times during this presentation, but you get the idea. And this proactive controls top 10, they take a different approach. Instead of focusing on vulnerabilities, instead of focusing on these are major problems in applications, they focus on these are the things that you can do as a developer to actually proactively address security. And that's their take on web security or security in general. And here's an overview of the 10 items that are in this top 10 of proactive controls. And you can see that they already take a totally different perspective. They start with talking about defining security requirements. Define upfront what requirements your application has with regards to security. That's not something you find in an offensive document like the OWASP Top 10, which focuses on vulnerabilities. And of course, they go further. They encourage developers to use security frameworks, to use security libraries, to avoid implementing security-sensitive features themselves and rely on the work of other experts. And it goes on, and of course, the usual suspect starts appearing there as well. Secure database access. That is to prevent someone from easily logging into a database server. That is to prevent things like SQL injection and topics like that. And if you go a bit further, you find other examples there as well. The security requirements item is actually quite interesting. So essentially, it encourages you to take a more structured process towards security. It discourages the use of this whack-a-mole game like, oh yeah, SQL injection, let's see, oh, oops, we had a problem here, let's fix it, and oh, we have a problem here, let's fix it. No, instead of doing that, just work towards something where you can proactively avoid these vulnerabilities in your application instead of having to fix them afterwards because somebody tells you, because you discover them by accident, somebody exploits them, or a pen test reveals them. And that is the goal of the proactive controls. The proactive is the keyword here. And again, it's a top 10 list. It's about raising awareness. It's about telling developers, hey, there's these things, these 10 things are a very good way to start taking security more seriously. Instead of doing this ad hoc thing, here's some structure you can more or less follow to actually get the job done. But of course, it's again an awareness document. It lacks the exhaustivity or whatever, not a native speaker, my apologies. It lacks that level of detail to be a fully guidable document, a document you can actually use to build your security program. If you look at one example, our authentication example, here it's called implementing digital identity. It's no longer called authentication, in part because it's based on a new NIST guideline that came out about a year and a half, 2 years ago. And that NIST guideline goes into a lot of detail on how to do authentication or manage the identity of an entity in your system. I highly recommend it to read it. It's actually really, really interesting. And this item in the OWASP proactive controls focuses on these different levels that the NIST standard specifies. So NIST considers level 1 of authentication or identity to use password-based authentication and has a lot of guidelines on how to handle that correctly. Level 2 is implementing multi-factor, and level 3 is really strict, and it's using cryptographic identifiers, devices that need or use a key and are uniquely identifiable to be in the possession of the user. And again, they're scratching the surface. The document actually says we are only scratching the surface here, because there's just no way to cover all of these guidelines in a single awareness document. It just doesn't work like that. If I give a training that involves authentication, I can talk about that for 2 days. I have material that covers all of these aspects for 2 days, which will drive a developer insane because there's just so much to keep in mind. And that's why these awareness documents keep it strict, keep it concise. One example is how to securely store passwords. The proactive controls mention this, like, oh, by the way, in case you haven't heard this, there's a better way to store passwords than simply plain text storage or using a SHA-1 or whatever. There are these functions like bcrypt that you can be using. And here's an example of how to do it in PHP. But of course, they don't give code examples for all other languages and things like that. That's not the purpose of the document. It's about triggering this bell, about planting these security seeds in the minds of developers to allow them to start thinking about security in a more structured way. So this top 10 of proactive controls is again about awareness. It mainly focuses on the do's. It's not, it's more the defensive side of things. It's going to say, like, if you do these things, then you actually start to integrate security, and you're taking it to the next level. And you can start building on top of that. You can start growing from there. And it's not going to tell you what to do first or how to do these things in detail. And that brings us to the OWASP ASVS, or the Application Security Verification Standard, which is a mouthful. But the ASVS tries to fill these gaps that the OWASP Top Tens leave. It actually tries to give you a set of security requirements and testing cases that you can use to build a security program, that you can use to think about the security of your application. And they are divided in all these different categories. So you have 16 of them. I know the numbering is a bit messed up. That's because of to keep track of issues across different versions of the document, but I've counted them. There are 16 issues. And you can see that they focus on the basic things first. Just like the proactive controls, they think requirements and threat modeling and architecture is important, and they're right. But the categories here are just divisions of items. They're in no way a prioritization. They just tell you there's all of these different things, and within each of these categories, there's a lot of items to take into account. This is from the first one, the architecture one. You can see it starts by saying that you should know what the components in your application are, and you should check whether they are needed or not. Because what's the point of keeping an administrative interface around if nobody ever uses it? Just increases your attack surface for no good reason. So maybe you shouldn't keep it in the application if nobody actually uses it and it's a superfluous component. And it goes deeper and deeper, and it actually gives you very concrete requirements. Of course, if you stay on the architectural and threat modeling level, these things will remain fairly vague. But if you go deeper, for example, malicious input handling, you'll see that they get really concrete. At the bottom, 5.10, you can see that it's about preventing SQL injection, that you should take that into account. And it also suggests a solution here. Again, it doesn't go into detail. That's not the job of this specification. But it tells you, like, hey, query parameterization is probably the right way of doing these things. And that's, again, a seed that you can use to look up what does this mean in practice for the language I'm using. If you're using a language with proper libraries, this is not going to be too difficult. If you use some exotic language that doesn't know how to handle SQL queries properly, that's going to be a real pain to address. Also notice the colors. That's not just to make things pretty, they actually have a use. And the use is they are levels of ASVS. So you can For each type of application, there's a different level. And the spec goes into a lot of detail, or the document goes into a lot of detail, what these actually mean for different sectors. So they explain like, oh yeah, for financial applications, these are how we see the levels. And for healthcare applications, this is how we see the levels. And the levels actually allow you to strive for certain levels of security. They help you to consider which things are important for you and which things may be less important or maybe overkill for the application you're building. Again, there's a lot of detail in the document, so I'm paraphrasing here on my PowerPoint slides. But essentially, opportunistic security is for everyone. If you're building something that you expose outside of your own computer, you should have at least a minimal level of security. This is something everybody should strive for, and there's no negotiating on that. And then, if you're building a serious application, so essentially all business applications fall under the category of standard applications, they should strive for ASVS compliance level 2. There's some additional items that they should be taking into account to ensure that they have covered most of the security-aware areas in their application. And then level 3 is for applications handling critical information. That's typically applications handling money, or a lot of money, point-of-sales terminals, which probably are at level 0 if you hear stories about those things. But healthcare applications that immediately affect the health of people, applications containing really sensitive data, examples like that belong in category 3. And based on these categories, you can go through this ASVS document and all of the different categorizations, and you can identify, oh yeah, these things are relevant for me. Because honestly, if you're building an opportunistic application, if you're building a public site where you're publishing public blog posts, then multi-factor authentication is probably not something you need to worry about. But if you're building a banking application, it probably is. Well, in Europe, we're kind of good. In the US, banking applications have different standards. ASVS can really help there. ASVS does two concrete things. First of all, it's supposed to drive security processes. You're supposed to use this document, not as a checklist, but you're supposed to use this to identify what should I be doing in my application. You can do this up front. You can use it to derive coding guidelines from. You can use it to identify which areas should be tested in your application, all of those things. It's really useful in that regard. It's a set of requirements. That's exactly what it aims to set out and what it achieves. And it also gives you a way to talk about security. Before, you've heard people say like, yeah, we're OWASP Top 10 compliant. It's like, what does that mean? Did you check the OWASP Top 10 and you don't have any of these 10 vulnerabilities? That's fine, good job. But what about the other 250? Nobody knows. So it's really hard to talk about what did you do security-wise without a full audit and a page-long report of identifying what does this exactly mean and what did they do, what they didn't do. With ASVS, you can talk about this. You can now communicate to your customers, we have achieved ASVS level 2. And that means something. Well, of course, you have different versions, so it's going to be ASVS 3.0.1 level 2. And then everybody knows, well, at least everybody familiar with the ASVS, which is all of you now, and other people, knows what that means. Same thing if you get a security audit, you can tell your auditor, like, we aim for ASVS level 2, and they know what they need to check. They know that well, essentially they don't have to complain about the lack of that feature if that's level 3. If that's something you're aiming to do next year, then that's also fine. And that's what the ASVS actually brings to the table. Let's look at our example from before. This is from category 2, which is about authentication. So you can see that there's, again, quite a bit of items here, quite a bit of detail in the requirements. So essentially, a few interesting things is verify that all authentication controls are enforced on the server side. Again, this sounds like something silly, but you might be surprised how many people still do authentication on the client side. If you want to lose some money, I can make you a bet that I can find an example on Google in 2 minutes. I'm not going to do it live, but we can do it over lunch. It's really that common. People doing JavaScript-based authentication, obviously people that don't really know anything about security, but proclaiming that as a good solution. And other developers find that and use that because they haven't been aware that this is a problem. Now it's in the spec. So now, if you're following the ASVS, if you're doing an audit based on the ASVS or using that as a secure coding practice, then you know that this is something you shouldn't be doing, and you should actually check whether that's not happening. And it goes on. There's about 30 items in this category. So there's quite a bit of these items here. Here we have things like not using default passwords. That's kind of important here as well. and the automation in place to prevent the use of previously breached credentials. And it goes on and on. And towards the end, things get a bit more complicated. So for example, 2.31 says, hey, by the way, you might want to offer multi-factor authentication. And if you're aiming for level 2, you should offer multi-factor authentication. Because yes, it is actually important. It's a different story of getting your users to use that, but at least offering them the possibility to do that, that's already step number 1. And again, it goes on and on. I'm not going to go over each of these categories in detail because that's going to bore you and it's also going to bore me. So let's not do that. So the OWASP ASVS is actually a detailed overview of do's and don'ts. It's not a checklist that you can use directly, but it's a starting point. It's something to tell you, like, in all of these areas, this is what's happening, and these are the things that you should be taking into account. And if you're building a simple application to keep recipes, then maybe level 2 is a bit overkill. But if you're building a high-value transaction application, then you might want to strive for ASVS level 3, and there's a lot of extra things that you will need to take into account. And one of the good things about these levels is it's not only about the application type, it's also about how much skill does it require from a developer to implement that. So if you have something that is really good security-wise, but requires a lot of complex configuration and development to actually implement that, it is likely to be a level 3 requirement. Because you don't want your developers to focus on that before they have covered the basic level 1 and level 2 requirements. And that's what the ASVS here brings to the table. So how can you use this? In the second part of my presentation, I'm going to dive into a few examples. So it's not a checklist. It's not something you use on a Monday morning to go to your desk and like, let's see what level we are. SQL injection. Yeah, I think we have that. Check. And go on and on. It doesn't work like that. If you want to see whether you're protected against SQL injection, you'll have to open up your code and look at your actual pieces of code that handle database queries. And you have to inspect them, each and every one of them, and see whether they actually handle SQL injection properly, yes or no. And only then do you have an idea of what you're doing at that point. So it's not a quick skim document, it's something you actually use to build a security program. It's something you use to dive into depth and decide, is this handled or not? If not, how can we handle that in the future? I'm going to show you a few cases of how you can actually use that and what happens if you don't. You may have heard about this. This is from last week. It tells you that I made the slides since then, but that's okay. I'm here and I'm presenting. This ISP in the US lost 73 gigabytes of data, including passwords, private keys, pictures of their infrastructures, just like that. Why? Because they had an Amazon S3 bucket, which was wide open to the internet. That's probably not supposed to happen. There's an ASVS item about this. We covered that. 2.19 says, verify there are no default passwords in use in the application. And that includes no password at all, by the way. And if you use this as a checklist, then you can look at your application. Oh yeah, my S3 bucket is secure. I'm good. Check. But maybe that changes tomorrow. Maybe someone changes something tomorrow that causes that authentication to fail. How would you know? Well, apart from being in the newspaper about this problem. You don't. And that's why you can use something like the ASVS to set up automated security testing. You should look at these requirements and you should think about how can I drive them, let them drive my security testing. And all of the level 1 requirements almost all of them are automatable in testing. So if you're using these public databases and public buckets or whatever, write a test for that security, monitor those things, because it will go wrong at some point. Maybe it's a misconfiguration, maybe it's a problem at Amazon, who knows? But you want to be the first to detect that, not an attacker passing by and grabbing all of that data. That's only one example of how to do things correctly. Let's stay in the authentication space. There's this website for adults to find friends. They got hacked and they lost a lot of information. Why is this relevant? Not because of the friend part, but because of the way they store passwords. They're using SHA-1 to store passwords, the largely discredited SHA-1. Well, it doesn't matter whether it's discredited or not, it matters that it's a hashing algorithm. If you store passwords with a hashing algorithm, you're doing it wrong. That's essentially the only thing I can say about that. I know it used to be done like that in the past, but today we have better alternatives. You shouldn't be using it anymore. One way to attack weakly stored passwords is rainbow tables. You can download a rainbow table and you can look up passwords that are plain hashes very easily. Simply give it a hash and the rainbow table gives you a second later or less than a second, bam, this was the password. And if you want to do this for MD5 from 1 till 9, it's a 690 gigabyte download. But once you have that, you can easily revert any MD5 of alphanumeric characters. Please don't download this on the network. Nobody is going to like you if you do that. Do it at home or at a hotel. Everybody's fine there. Anyway, even if you can't use rainbow tables, let's say that someone is using salts. I know I'm skipping quick here, but you're using salting, so rainbow tables are out. People can still brute force your passwords if they steal them. Brute forcing is really, really powerful. People just buy a lot of NVIDIA hardware, which is thriving, by the way, to crack passwords and mine Bitcoin as well. But essentially, a rig like this is really, really powerful. And in case if you don't believe me, this is what always shocks people in my training. If you look at the number of hashes per second such a thing can do, if you're using MD5, it's that much. Well, if you put a number to it, it's 200 billion hashes per second. That means you can try 200 billion different passwords per second to see if they match against the hash that you have stolen from the database. That's insane. For SHA-1, it's better. It's only 68 billion. So we're getting better there. But this is a problem. That's why you cannot use SHA-1 or MD5 or any hashing algorithm to store passwords. Because if you do that, it's going to be fast to break them. Because these algorithms are used in situations where they are supposed to be fast. We actually want them to be fast. SHA-1 was, I think it still is, part of Git. You don't want to wait like 10 minutes to do a Git commit. It just doesn't work like that. It needs to be blazingly fast. But today we have these password hashing functions like bcrypt. And the best practice today is bcrypt 13. And the machine that we saw before can do 390 hashes per second. That's not a typo, 390. That's how you store passwords. Because if then in the worst case scenario, somebody steals your database, they have the passwords, they're not going to be able to brute force them in any way. It just doesn't work like that. Well, they might try some silly passwords that people shouldn't be using, but a straight up brute force attack is not the way this thing works when you use bcrypt. And it brings us to 2.13 in the ASVS. Verify that account passwords are one-way hashed with a salt and with a strong brute force protection. A sufficient work factor needs to be involved there. It's there. You can check it. Brings us to this use of the ASVS. Use the ASVS to build up secure coding guidelines. Again, it's not a document that you just take, you drop on a developer and you say, do security. It doesn't work like that. But as a team lead or as a manager or even as a developer from the bottom up, you can derive secure coding guidelines from this. Fixing 2.13 is really easy by using a library that supports bcrypt or scrypt or argon 2. And if you do it like that, the problem goes away and you are compliant with this. Of course, you also write a test to make sure that you're actually doing that correctly, but that's the way this thing works. Of course, the ASVS goes into a lot more depth, and you have these different levels. And here's an example of what a level 3 problem might be. This is a snippet of code to handle the user's login, and you see that there's a few different code paths. So what you see here is the check for the password. Behind the scenes, this is using bcrypt. It's not shown here for brevity reasons, but this is using bcrypt. So if the authentication is successful, we're good to go. If the authentication fails, here, then we return an error. We log an error and we return the error page. And if the user is not found, we also return the error page. Sounds good, right? This is a proper way of doing things. Well, sure, but it allows something called username harvesting or username enumeration attacks. And why? Because you can use a timing attack now. Because remember, this is checking a bcrypt hash, which is slow, and it's going to take about 100 to 200 milliseconds on your system. While this code path is instant. It just returns, oh yeah, I didn't find that user, bam, there you go. So if you're on a reliable network, you can actually find, using a timing attack, you can find whether a user account exists in the system or not. That is something you're very unlikely to come up with yourself. You have to be a really good security-aware developer to catch that while you're writing code. I'm not sure whether I would catch that. I'm a security guy, not a developer, so maybe that's the problem. Who knows? Anyway, the ASVS does cover that. Somebody else thought about this and put it in the ASVS, like, hey, this is potentially a problem. 2.28. But also note it's a level 3 problem. It's something you want to worry about. If you've covered everything else and you're building a highly critical application, yes, this is something to worry about. The solution is not that hard, by the way. You can easily calculate a fake bcrypt hash in each of the code paths and the problem goes away. It's just a bit slower, that's true, but you don't leak this information. So the ASVS actually helps you to prioritize your security efforts, because it's no good to implement something like this first without having fixed this glaring SQL injection or command injection hole in the application. So you should focus on level 1 first, then level 2, and then level 3. Of course, it's not strictly linear. You can mix and match a bit, but there is some prioritization in there to take into account. And that's what the ASVS offers you. Talked about multi-factor authentication before, so you should offer multi-factor authentication. There's a lot I can say about that, which I'm not going to do because time is running out. But the most common way today to do this is using TOTP, which is an open protocol, also best known for use in applications like Google Authenticator. I myself, I'm a bigger fan of Authy, but this is what most people know. How does it work? Well, essentially, if you enable this mechanism, the server generates a secret, keeps it himself, and gives you the same secret using this QR code, which you can install in your cell phone. And whenever you need to provide a code, it's using system time to sign something with that secret. Doesn't matter how it exactly works. Protocol is implemented in the libraries anyway, so you don't need to worry about that. What matters is you get a code, you send that code to the server, and the server can verify whether that code is associated with the secret that only you know, only your cell phone knows. And if that's the case, then the server knows, oh yeah, that guy got the secret earlier, and now he has proven possession of that secret again, so that is sufficient as a second factor. This is how these things work in practice. Sounds good, right? Well, yes, of course it sounds good. It's definitely a good requirement, but again, if you implement this, there are some things that you might want to take into account. For example, wouldn't be the first application that stores these secrets as plain text in the database. Meaning that if somebody comes along and finds a SQL injection vulnerability with a union select, they can start selecting stuff from other tables. So here they select stuff from the users table, grab the TOTP secret column, and add that to the search results of this original query, which gives you a list of restaurants in this application. Only here, it now doesn't contain restaurant information, but it contains user information. Here's an example of the secret from this user, and here's an example of a secret from that user. And if you can steal these, you can start generating codes in name of the user. That's all you need to start generating these codes. So again, you need to focus on prioritizing your security. Because if you look at 5.10, it says like, oh, by the way, the SQL injection thing is kind of a problem, so you might want to fix that as well. But it also shows that at a certain point in time, you're going to outgrow the ASVS. Because it is a standard built by very smart people, by experts in their field, but there's some limitations. Everybody does something different. You have your own unique scenario, so after a while, you might want to start expanding on that, you might want to start customizing that, and you might want to work towards your own internal procedures. And then you can start adding new things, like verify that shared secrets should be stored in an encrypted way. That would solve part of the problem here. So the last message here is fork and customize. This is actually encouraged by the authors of the document. They acknowledge that the document is not perfect. They acknowledge that there's always going to be some subjectivity in there. So instead of arguing about, yeah, should this be there or should this be there, you can, of course, ask these questions, but instead of having a religious discussion about these things, just build your own mechanism. Because if you're stumbling onto problems like storing the TOTP secrets encrypted in a database, you're already doing a very good job. If you have covered everything else from the ASVS, then you can start thinking about these advanced things. But if you have covered everything from the ASVS and you're sure that you have done it right, you're doing a better job than 95% of your colleagues out there, which is unfortunately the scenario that we're in today. So this document will actually help you to get started. It gives you a structured way to make things happen. And once you have bootstrapped that, once you have everything in place, once you have secure coding guidelines, you have automated security testing, you have focused penetration testing, you maybe have a bug bounty program. Once you have all of that based on a strong security program, then you can start thinking about adding additional stuff, about taking it to the next level and seeing what matters for you. Final word, this was about ASVS 3.0.1. ASVS 4 is coming out, so they're actively working on that. It's open, it's on GitHub. Somebody made changes yesterday after I sent them an email like, hey, why is this like that? It's open, so contribute. If you have something to say about this topic, participate. It's OWASP, it's supposed to be open. That's the whole point of having OWASP and having the community, that you get feedback from that community. So yes, you're highly recommended to join that process and actually help improve the ASVS towards the future. And that brings me toward the end. What's going on? Okay. That brings me towards the end.